Hi guys, it's Mrs. Jacqua. We're recording Unit 7 pretest for triangle relationships on Core 4. Let's get going. Okay, so what we want to do, I think I have one for everything. No, I don't. I think I only have one. Okay. What we want to do is we want to look at what the altitude is. The altitude is a perpendicular distance from the top to the bottom. And so what I'm going to do is I'm going to analyze my perpendicular lines and go from there. If I look at this perpendicular line, it's going up and it didn't meet the vertex. However, if I look from E to D, it's going from the base of the triangle if you turn it sideways. So this is going to be DE, line segment D. Okay, what's a perpendicular bisector? All right, so we're going to do a similar thing. We're going to find where my perpendicular parts are and which one bisects it. Well, this one's got the tick marks there. And so my perpendicular bisector is going to be line G. So line G is my perpendicular bisector. So I'm going to delete everything so I can write on the board again. Now what is my angle bisector? Angle bisector means I want to have arc marks that look the same. So that's going to be CF. Okay, and name a median. A median bisects my sides in half, and then it goes from the midpoint to the vertex. So that would be AB. Cool, so let's go look at the other stuff. All right, AC is a median. So if AC is a median, that means that equals that. BC equals CD. So let's go see which one says that. Oh, C does. All right, next problem. AC is an angle bisector. So if AC is an angle bisector, what that means is this angle will match that angle. That's what an angle bisector means. So which one tells me that? That would be B. Alrighty, let's look at number 7. AC is an altitude. If AC is an altitude, what that means is that's 90 degrees. There's a 90-degree thing. So let's see which one says that. Oh, that would be A. All right. Draw the appropriate lines to find the centroid. So what I'm going to do is I'm going to show you a really cool math website. Ask me later. mathisfun.com. And I'm going to type in here triangle centers. And I'm going to select triangle centers. And guess what? It's going to tell me how to find a centroid. Okay, so if you can read that, it says centroids, draw a line called the median from a corner to the midpoint opposite side. Where all three lines intersect is a centroid. This website's really cool because I could drag my triangles around, by the way. Anyway, I thought that was really cool. So my centroids are my medians. So what that means is I'm going to use a ruler and I'm going to decide that there's my midpoint for that one. That side equals that side, connect it to the vertex. All right, find my other median. That side equals that side, connect it to the vertex. All right, so then find my other median. Draw a point, connect your dots. Use a really cool ruler so yours turns out better than mine. It's hard to use a ruler on an iPad, by the way. And so this point in the center is a centroid. Now the super cool thing about the centroid is if this red part is x, then this upper part is 2x. The relationships are in threes. Okay. Draw the appropriate lines to find the circumcenter. So let's go find out what a circumcenter is. Circumcenter is drawn from three perpendicular bisectors. So let's go look at that. It's kind of cool. My circumcenter can go on the outside. On the line, it's when you have a 90-degree angle, and on the inside. Anyway, it's cool. So those were perpendicular bisectors, right? Yeah. So what I'm going to do is I'm going to find my midpoint. That side equals that side, and go straight up. Find my midpoint. Use a ruler, guys. You gotta have markings like this. Find my midpoint. And you really ought to have those boxes too. So there's my circumcenter. Now what my circumcenter means is that hypothetically, if I was to take my circumcenter and go to all three vertices, it's going to be the same distance, and I can do a circle with that as my radius. Oh, I didn't do a very good job. That was a little bit better. Gotta go out. All right, there. Get the idea. That's my circumcenter. Okay, let's draw an in-center. Okay, let's go to a really cool website that you're taking notes from. The in-center is from all the angle bisectors. Push pause and read that. So I'm going to take my angle and I'm going to create an angle bisector. That side equals that angle equals that angle. This angle here, bisect it. Now use a protractor to do that, because those are cool. Oh, I missed it. Okay. Didn't show up. Let's do it again. There it is. So this is my in-center. It's funny, I identified that it was a typo, even though it's not. It's my in-center. Now with my in-center, the super cool feature is if I go to all three, whoops, that's got to be that way. All three of those, the edges, then I can draw a circle on the inside. Cool, it's my in-center. Oh yeah, the centroid was the center of mass, which is really cool too. So orthocenter, let's go find an orthocenter. Orthocenter comes from drawing and connecting all three altitudes. And now notice my orthocenter can be on the outside and the inside, and it can actually be on a triangle, but it has to be a right triangle. Cool. So let's draw all three altitudes. Spitting distance, remember if you're at G, you're spitting down. That's my altitude. I'm going to rotate it so I can do it for F. Spitting down, that's my altitude. And H, if I have a H and GH is my base, spitting down, that's my altitude. And there's my orthocenter. Cool, use a ruler, guys. Okay, if PO is an angle bisector of MON, find the value of X. What that means is this equals that. And so this equals that. So we're just going to work it. If I have 2x minus 10 equals x plus 15. Okay, I'm going to do two steps at once. I'm going to add 10 to both sides. I'm going to subtract x from both sides. So then I get x equals 25. There you go. Okay, if point E is a centroid of ABC, BD is 12, EF is 7, AG is 15. They want to find ED. If that whole thing is 12, what's 12 into parts? Into 3 parts. Well, that's 4, 4, 4. So the longest side is 8, the shortest side is 4, so ED is 4. Cool. Okay, list the angles in order from smallest to largest. Okay, so what I'm going to do is we're going to start with the smallest. If this is the smallest side, then that's the smallest angle, which is I. Then we're going to go to the next smallest side, which is 2. That's the smallest angle, H. Now we're going to go to the largest side, largest angle, G. Okay, you're done. Shortest side is longest side, so let's start similarly. Where's my shortest angle? So that's my shortest side. Go to the next one. 55 is my next angle, and its medium size is PR. And then we have angle 80, which is opposite QR. So QR is the largest side. Super cool. Okay, find the shortest segment. So what I'm going to do is I'm going to look. Here's my shortest angle, and that's its shortest segment. Here is my shortest angle, and that is its shortest segment. However, this red line is also opposite my 65. And 65 on this triangle, on the yellow blocked out, 65 is the biggest side of that triangle. So therefore, XY is shortest. Oh, not C. That's funny. Shortest. All right, cool. So 17. This one I have a typo in it, so fix it. PU. It's supposed to say PU. If PU is the median, PU is the median of PTQ, what that means is that it's going to be congruent to that, TU and UQ. If UQ is 6, then what's TQ? That would be 6, and this would be 12. 12. Alrighty, 18. If BD bisects ABC, find the value of X. Now what that means is this sucker equals that sucker, because we know that we have angle, angle, we have side, angle. Oh, hold on. Let's do it right. We have angle, side, angle. So from ASA. ASA, we know we can say 2x plus 30 equals 3x minus 4. So we're going to do 2 steps at the same time. We're going to add 4 to both sides and subtract 2x. And then I get x equals 34. So x is 34. Now 19, find all possible values for angle 1. Angle 1 equals, I'm going to write this as 2 and 3. Angle 2 plus angle 3. That's what it equals. So what do we know? We know that it at least is bigger than 62 degrees. And it's got to be less than 180 degrees because it can't be 180 degrees, so it has to be A. There you go. And then number 20, find the value of X. So let's look at this. If this is 15, we know that this will also be 15. So we're going to take the parts. X plus 3 plus 5. Subtract 8 from both sides. Oh my goodness, this thing is frustrating. And then we get x equals 7. Cool. Okay, choose the assumption you would make to start off an indirect proof. Now, when we're trying to prove something and we're trying to prove it indirectly, we assume that what we're trying to prove is not right. So if 1 and 2 are not supplementary, we're going to try to prove that they are supplementary. And we'll find a contradiction, and then we say, therefore, it can't be. Okay, which of the following won't work? So we're going to add the smallest numbers and make sure that they are still smaller than the biggest number, or that they're bigger than this. Hold on. Add the smallest numbers together and make sure that they're bigger than the third side, because it's A plus B has to be greater than C. B plus C has to be greater than A, and A plus C has to be greater than B. So, and where this falls apart, so let's look at A. We have 9 plus 4. Is that greater than 12? Yes, so that one is a triangle. Let's try B. Let's do the smallest sides. 1 plus 2, is that greater than 3? No. So, oh, can be the lengths of a triangle. Back up, back up, back. There, okay. So this one cannot be a triangle. And let's look at C. If I do 5 plus 5, is that greater than 10? No. So that one can't be a triangle either. And then if you do square root of 2 plus square root of 5, that's 1 point something. This is plus 3 point something. And it's got to be greater than 4 point something, and it's not. So B, C, and D don't work. Cool. Okay, writing an inequality, compare E, F, and G, H. So let's first identify where E, F, and G, H are. E, F, and G, H. Okay, so what we're going to look at for that one, let's look at this angle for, that is 23 degrees. So this one matches up with it. This one is 20 degrees, and that side matches up with it. So what that means is a 23 dude, 23 dude, 23 dude, GH is bigger than EF. I think we're done. We're done? Nope, write an inequality, compare angle 1 to angle 2. So here's angle 2, here's angle 1. Angle 2 is coming from 11, angle 1 is coming from 12. So angle 1 must be bigger than angle 2. That's your hinge theorem, dude. Alrighty, I think we're done. Alright guys, later.